This video is on the objective Understand Properties of Linear Equations. Alright, I'm hoping that you remember some of your old algebra classes that I'm sure you have taken before this statistics course, because everything we're going to see here is hopefully again something you've already seen about linear equations and the graphs of lines in the xy plane or the Cartesian plane. So before getting into this question, again, if you want to read more about the topic, click on More Instruction and look at their videos, their notes, their examples, and hopefully those help you out. In fact, I've got a little bit of it right here that I want to go over, so I don't have to write it down. So, properties of linear equations. Now, what we're going to be dealing with in this chapter is something called linear regression. Okay. Linear regression for two variables is based on a linear equation with one independent variable. The equation has the form y equals ax plus b. Now you're probably familiar with y equals mx plus b, where m was the slope, right? So this is the same, except instead of m, they have a. So a will represent the slope of some line, where a and b are constant numbers. In this equation, right, the variable x is the independent variable, right? The value I can choose, the variable I can choose a value for. And then once I choose a value for x, y is determined. Right? You can't just choose a separate number for y. Once you choose a value for this independent variable x, the value of y, see, depends on that value of x that you chose. So they would say that y is the dependent variable. So yeah, typically, like I was saying, you choose a value to substitute for the independent variable x, and then solve, for the dependent variable, right? What is the value of y? Now they have a very simple example here. I'll let you read that. Notice that they be careful. Right? I know they said they have ax plus b. The number attached to the x will be called the slope, right? This a, and the plus b, the b, the term without x attached to it, that's going to be called the y-intercept. And that may sound familiar to you. So be careful if an equation is written like this. See how the x term is the second term instead of the first term. All right, so the x term has this -2 attached to it. So -2 is going to be the slope here. And then the term without x attached to it is 15. Right, so 15 would be considered the the y-intercept, or the y-coordinate of the y-intercept. And then what they're doing here is having you plug in a value for the independent variable x, plug in 4, and calculate, you get y equals 7. What would be the value of the dependent variable? Alright, so what are the graphs of these things? How do you graph these lines? What do they look like? So the graph of a linear equation of the form y equals a times x plus b is a straight line on the xy plane. Right, any graphed line can be described by this equation. The only exception is a vertical line, and again, we're not going to be really dealing with vertical lines here, so I wouldn't worry so much about that. For the linear equation y equals ax plus b, as I've mentioned above, b is called the y-intercept. Right, that's the number without a variable attached to it, the constant term. And a is called the slope. Right, and a is the coefficient, the number attached to the variable x. So again, hopefully from algebra you recall that the slope is a number that describes the steepness of a line. And the y-intercept is the y-coordinate of the point, 0, a on the xy plane, right? The point that's on the vertical axis, the y-axis. So here, 3 possible graphs are shown. If you're graphing your line and it goes from the lower left to upper right like this, the value of a, right, the slope, will be positive. It'll be greater than 0. If the graph of your line is totally horizontal, right, it doesn't go up or down, then the value of a, right, the slope, will be 0. And if the line goes from the upper left to lower right like this, say it's decreasing, the values of y are decreasing as you move from left to right, then the slope in this case will be negative, right, less than 0. So they show you some examples of, here's y equals 2x minus 1. And again, I'll describe for you the slope on this picture. See, b is minus 1. If you plugged in 0 for x, y would be negative 1, so you see the point 0, negative 1 down here. And then when they say the slope is positive 2, when the slope is positive 2, that means if I increase x by 1 unit, so I go to the right 1 unit, so from x equals 0 here to x equals 1, I have to move up 2 units, right? If you have a positive slope, it means you're moving up. If you have a negative slope, it means you're moving down. So from this point, and this is really from any point on the line, if I move to the right 1 unit, I'd have to move up 2 units, you see, to find another point on the line. And this continues forever. I go right 1 unit, up 2 units. And the same goes for if you go left 1 unit, you'd have to go down 2 units. And remember, slope is rise divided by run. Either way you do it, it'll be positive 2. Alright, and then they explain that all here. Alright, so some key terms. Now, we'll get into in other objectives, other videos, this concept of linear regression, which is the process of finding the best fit line. Right, because what you're going to have is a bunch of pairs of data, right, and make a scatter plot. I know it's been a while since you've seen a scatter plot. And then look at all those points of data, and you're going to try to figure out what is a straight line that I can run through this plot of data and get as close to fitting all the data as possible. All right. So that's called linear regression. They mention independent variable, which is, in these equations, the variable x. Also has these names of, explanatory variable, predictor variable. The dependent variable, the y in these cases, also called the response variable. And then y-intercept and slope, and then you have some problems. So let's get into the question. So here, a botanist is interested in flower growth around the fields of her house. She finds the flower growth, G, is dependent on the number of minutes of shade the flowers receive every 2 hours. So X, right? X represents the number of minutes of shade the flowers receive every 2 hours. And G represents, the growth of the flower, and it looks like in centimeters on the graph here. And this can be modeled by the following function, G of x, which is like y. Okay, remember function, hopefully you remember function notation from a previous algebra class. This just means G is my output, x is my input. All right. G of x, or G, or just y if you want, equals 20 minus 3x, or if you want to write it in the way that we've been seeing, the ax plus b, this would be negative 3x plus 20. And I'll write that on well, I don't think we need to write that. So they're asking us to draw the graph of the growth function by plotting its g-intercept, right? Because again, the output's called g instead of y here, and another point. All right, so I will draw something. All right, so I'm going to go with some paper, and I'll make a rough sketch by hand of this growth function, this linear growth function. So again, we're given this model, right? G of x equals 20 minus 3 times x, which again is the same thing as negative 3 times x plus 20. Right? If you like it in this order, right, with the x term first. So what I'm seeing here is, it's in that form, and you can call this the y if you want, and look at it this way, y equals, but it's the same as g. G is the output, y is the output, and x is my input. And it's in that form, y equals ax plus b. So the value of a here, right, the slope, is negative 3. Right, that's the coefficient on the x term. And the value of the b, right, that y-intercept, or in this case the g-intercept, is the positive 20. All right. So if I make a set of axes, all right, so we have a horizontal axis which will represent possible values of the independent variable, so possible values of x, and then a vertical axis which will have possible values of the dependent variable, or the response variable, which is g or y, if you wanted to call it that. And every point on the plane represents an ordered pair. Right? And the ordered pairs here will be an x value, comma, and then a value of growth. The number of minutes of shade, comma, the growth in centimeters. So each point will take on this form. Again, usually it's independent variable, comma, dependent variable. Alright, so I said already the y-intercept is 20, right? So let's say, again, I'm making a very, very rough sketch here. So here's 20 on the vertical axis. And here's the point, 0, comma, 20. So that means even if it gets no shade, right, 0 minutes of shade, the plant will still grow 20 centimeters. Alright, then the slope being negative 3 means the following. It means if I go, increase x by 1 unit. Right, so again, this is a very, very rough sketch. I increase x by 1 unit. This tells me when I increase my input by 1 unit, the output has to go down 3 units. Right, this is a slope of minus 3. So if I go from 20, down 3 units would be 17. So here's another point on this line, 1, comma, 17. Right? So if they got 1 minute of shade every 2 hours, the plant would only grow 17 centimeters. And then once you have 2 points established, that's all you need to be able to draw a straight line, right? The rest of the points should fall on this line here. And here's a graph of the line. Now, some of these points don't make any sense at all in the context of this problem, because the points over here are meaningless. Because what does it mean to have, we have negative values of x over here? So these points are meaningless. Because what does it mean to have negative minutes of shade? It doesn't mean anything. It has no meaning in real life. Same thing over here. Now you're going to see it in our graph, but these points below the x-axis are also meaningless. Well, maybe not. Maybe not. Actually, this might mean the plant shrinks, because we have growth up here. Yeah, perhaps after, once we hit the x-axis, after you hit the x-intercept, these values have, negative growth values, so maybe the plant shrinks. Okay, so these have more meaning than these points. But either way, this is how we're going to be graphing a line. So on my picture here, right, we're moving some points. Move this intercept here to 0, 20. And then this point to 1, you can move it to 117, like I had, like that. There, and there's your graph of your growth function. Now if you didn't like how close these were, again, you could keep using the slope to find other points. 117 would be on it. Increase the x by 1, you decrease the y by 3. 214 would be on it. 311, 4, 8. All sorts of points could be found using the slope. But that's it right there. So I submit. Wonderful. And again, very easy. I'm hoping this is a very easy objective for all of you who have taken some sort of algebra class. See, 4, 8, 5, 5. They plotted 5, 5 here. All sorts of points, right? There are infinitely many points on a line. All right. So again, very, I hope, simple stuff. Hopefully watching me do this, going over the more instruction, reading the answer explanations when they come up. I'm hoping all this stuff helps you out when you're working on this material on your own. And thank you very much for watching.